Okay, for 9-4, we're going to do a lot of review of our different types of transformations when we do these compositions. So when we're talking about a composition, we're just talking about transforming a figure. And we're going to talk about doing that 2 or more times. Technically, a figure could be transformed lots of different times. We're just going to really just do it twice for the sake of our examples. Sometimes the graph gets a little crowded if you do it more than that. The way we're going to label these compositions is we'll have, let's say, point A, and maybe we need to reflect it first, so we're going to call that next one A prime. And then when we transform it again, we're going to call it A, this is called double prime. So it just looks like 2 of those little apostrophes. It's called double prime. There is one type of composition that has a special name. It's called a glide reflection. And a glide reflection does those 2 things. So a glide reflection is a translation followed by a reflection. And the order that you do those things is really important. It has to be the translation first, then the reflection. For any composition, do whatever one it says to do first, and then follow it with the second one, because sometimes the order will make a difference with how you have those done. Okay, and then this next word, isometry, you just need to know that that is a congruent transformation. Everything we've done so far has been an isometry. Everything we've done so far has been congruent if you did the steps right. And we need to know that compositions are isometries also. So all 3 of your shapes, the image, the pre-image, and then the final answer will all be congruent, and that's going to be one way we can kind of double check. So we're just going to go through a lot of examples now and see how these work. If you want to try to work ahead a little bit, that's fine. Just make sure you're double checking as we go. These first 2 are both glide reflections. You want to first of all perform this translation with this vector being -2, -4. Remember what that means is it's going left and then down. So take each point, go left 2 and then down 4, and make sure that you label these. This first one would be K prime, left 2 and down 4. We have J prime, and left 2 and down 4. There's L prime. Then you can draw your triangle in. If you want to use a ruler, that's great, or some other sort of straight edge. Okay, I'm not done though. This is not my final answer. I then need to take that image and reflect it in the y-axis. So in my case, it's the red one, and I'm reflecting this in the y-axis, so the y-axis being here. I'm going to take each one of those points and go the same distance over that line. So L prime is 3 units to the left. I need to go 3 units to the right. And again, make sure you're labeling that. This would be called L double prime. J prime is 8 units to the left. So I'm going to go 8 units to the right. And that's J double prime. And then for K, K is 5 units, so I'm going to go 5 units to the other side, and that's K double prime. So go ahead and take a second to draw that triangle in. You can see that all of these triangles are congruent. They're isometries, and we're done with that one. One thing that students do mess up on sometimes is they want to reflect that original one. Okay, again, it's like a series, it's a process. This is your first one to your second one, and then it's your second one to your third one. Okay? If you want to do this one like lightly dotted or something, this is your final answer if you had to like write out the coordinates. Okay, I'll do the same order. I'll do the first one in red. This translation being 3, 0 means I'm going to the right 3 and then not up or down at all. So just take each point and go to the right 3 and label them. So we have L prime, we have K prime, and we have J prime. Draw your triangle in. And I made this example just so you guys could have another try at it. I'd say this here is probably the hardest one to do. We have that line y equals x. You have to first of all remember that that kind of goes through the corner of all these boxes, goes through the origin, has a slope of 1. And I gave you a couple different ways to do this. If you're telling how far it is away from that line, you have to count the diagonals the opposite direction. So if you're looking at L, that's like half a diagonal box away. You're going to go that same distance on the other side, and that one's L double prime. For K, that is 1, 2.5. So you're going to go that same distance on the other side. Or does anyone remember the rule for this one? You could switch the coordinates. So remember how I said I don't really like teaching the rules, but if you want for this one and this one alone to remember, the rule is you just take those two coordinates and switch the order. Like for J, that's at -3, +2. So J double prime would be at +2, -3. If that helps you be able to see, this is also 1, 2.5 diagonal, so you can go that same distance on the other side. Either way, whatever way is going to work for you is fine. Just make sure you have a strategy for that one, because that's the one that students get confused on the most. It's not that you're just counting straight left or right or straight up or down. So this would be the composition for that. So for this first one here, not a glide reflection anymore. What I want to do is first rotate and then translate. There's no special names for any of these. It'll just tell you what to do. So this first one I'm rotating 90 degrees counterclockwise. So that's going to take this from the first quadrant and kind of move it over here to the second one. When I take that and rotate, I will jot down where these coordinates are. Again, if you'd rather use that scrap paper, totally fine, but I'll just do it this way because this seems to be the preferred method. So let's see, T prime looks like it's now at -5, 2. S prime looks like it's at -4, 3. R prime is at -2, 2. And Q prime is at -4, 1. So I'm going to just turn that back and graph those points. Again, make sure that you're labeling these. And you guys could just kind of do this on your own also.
It's kind of difficult to see.
It is? Okay, I'll draw it with a pen if it's too difficult to see. Is that better?
Yeah.
Okay, so there is the first image. Again, this is not my final answer. I need to go through and do the next transformation. So that next transformation says I want to translate this along the vector 0, -4. So that means I'm not going left or right at all. I'm just going down 4 units. So I'm going to just take each one of those points and count down 4 units. and label them. So this is Q double prime. We have R double prime. We have S double prime and T double prime. So if you have some different colors, that would be great. If you don't have different colors, make one dotted and one solid, or trace over the final answer a couple times just so it looks different. This one's not too bad because they're not overlapping. Sometimes when they start like overlapping a lot, it gets pretty confusing with what's going on. Okay, and then the last example, we want to rotate that 180 degrees clockwise. Again, for 180, it doesn't really matter if you're going clockwise or counterclockwise, but I'll go clockwise just for the sake of this example. So this would be 90, and then we have 180 here. It looks like this is now down here in the fourth quadrant. If you want to jot those down, we have Q prime is at 4, -1. We have R prime at 2, -1. P prime looks like it's now at 5, -3. And S prime at 1, -3. Go ahead and turn this back around, and then I'll do these with the pen. Okay, so go ahead and take a minute. It's probably easier if you just graph them on your own than trying to watch this while you're doing it. We have 4, -1, 5, -3, make sure you're labeling those points as we go. Okay, and then the last thing we need to do is we need to reflect this in the line y = 1. So where is that line y = 1? It's the horizontal line through where y = 1. I always like to draw that in. I draw it in as a dotted line. Could make it solid, doesn't really matter. But make sure that you're counting the distance to that line and not just the x-axis. So point R is 2 points below. You're going to go 2 points above that. Label that R double prime. Q is the same. For P, it's 1, 2, 3, 4. So you're going to go 1, 2, 3, 4. And that's going to put S double prime right there. Again, you can tell that these are isometries. They're exactly the same size, all three of them. We could, potentially you could do like another one, and another one, and another one. Your graph paper will just get kind of full. So for the sake of these examples, we'll do like up to 2. But if you think about like machinery or something in a factory, like those robotic arms, you know what I mean? They're like constantly like taking those parts and rotating them and translating them and maybe even reflecting them if they have to flip something over. That would be like a whole series of transformations as something moves down an assembly line in a factory. Okay, and then these next couple things, I want to show you the examples and then I will give you the rule for them. The rule's pretty easy. These will be on the test, but you have to make sure you understand what's going on for those. Okay, and I guess I had some lines drawn in on this graph paper, but they're really hard to see where they were at. So if you want to take a second and go ahead and draw these lines in. That first line is 2 units below that triangle. And then the distance between those lines is 1, 2, 3, 4, 5, 6. 6 units between those 2 lines. And it's important that you get that set up right, so when we do this double reflection over those parallel lines, this will work out. For this one, I probably wouldn't use the mirror. I would just count it. When we do the next one, use the mirror for that one. So if I'm reflecting this triangle in these parallel lines, because this is 2 units above, I'm going to go 2 units below. I don't need to label the points because there weren't points drawn in there. This one here, 2 units below. And this one looks like it's 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5. And I get that reflection there. Then if I take this one and reflect that again over these parallel lines, this is only 1 unit away. This one here, 1, 2, 3, 4. So that same distance. And 4 units again, that same distance. My overall end result after those 2 reflections in those parallel lines ends up being the same as if I would have just translated this. Okay, so the overall result is a translation, and we can actually be a little more specific than that, because this translation, if you look at like one of these points to its corresponding point, if I count how far apart these are, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can say that it's a translation, 12 units, and if you want to say like vertically down or something to describe that a little more, you can. This would be what I'm looking for when it's on the test. And it is not a coincidence that these numbers are what they are. This translation will always be always a translation 2 times the distance between the parallel lines. And that works when you have parallel lines. It's always going to be a translation twice the distance between them. So if it would have been like 10 units between them, you could just say it's going to be a translation 20 units. You don't actually like have to graph it out to be able to tell that. Okay, the intersecting lines is a little different, and this is where I would use the mirror if I were you. See if I can get this on there so you can kind of see it. Let's see. Oops. Do your best. So there's the first reflection. This is really hard to do like while looking at a computer screen and trying to make sure that this shows up on the video. Okay, and then reflect it again. Let's see. Should end up something like this, and actually I'm going to put a point on here. I'll just label 1 point. If you want to label both, that's fine. Hopefully you can tell that this is not a translation. When you have these intersecting lines, what this actually ends up being is a rotation. So parallel lines, it's a translation. If they're intersecting lines, it ends up being a rotation. And let's just say that this is 70 degrees, just to make something up. What this rotation will be is it will be 140 degrees. And that would be your answer for either the coursework or the test or the quiz or whatever. And the way you're going to know this is if they're intersecting lines, it's always going to be a rotation 2 times the angle measure that's between the lines. So the next thing is just the way that these questions are going to look. Don't overthink this. If you know these rules, then you'll be all set, and these questions should go pretty quick. Down here at the bottom. Okay, so figure B is reflected in line L, and then line Q. Describe the single transformation that would map B to B double prime. So you don't actually have to do the reflection. If you want to, you can. But what single transformation would happen if you reflected this twice over these parallel lines? It'd be a translation. And then to describe that, because this is 3/8 of an inch between those, you could just double 3/8 of an inch. So it'd be 6/8, which is the same thing as 3/4 of an inch. So you could describe that as a translation of 3/4 of an inch. Okay, for this one here, if it's going over N and then going over Q, it would just be rotating. And I could say that it's a rotation of 50 degrees. If you wanted to be more specific, you could say like 50 degrees counterclockwise. But as long as you have those things, I'll give you credit when you're taking the test. Okay. Some of the things in the book might say that you have to sketch it out. If you want to, that's fine. I'm not going to require that on the test though, so if you just want to practice doing it this way, I think you'll be all set.